This video is about applications of double integrals. First, let's look at mass. Here's the problem. We'll have a region D here. Think about this is a very thin plate. So thin, we just ignore the thickness. Now, I want you to find the mass of this very thin plate. If the density, we normally use a rho to stand for the density. If the density is uniformly distributed, in the other words, say density independent, say every point your density is a constant. If this is a constant, simple case, how did you find the mass? Obviously, for this case, your mass simply is area of D of this region of your plate and the times density, right? That's it. However, in the real situation, it's almost impossible for your density to be a constant. So if your density at different point, they take a different number. If that is the case, how do you find the mass? So this is the old idea. What we can do. The problem is the density is not constant anymore, so we don't know how to do that. So you can break your region to many small rectangles. This area we'll call it dA. This is the dx. This is the dy. dA can be written as either dx times the dy or dy dx, right? Okay, so make this area small enough such that so small you can treat the density as a constant in that small region. So density times dA will give you approximation of the mass in that rectangle. Then we'll have so many of such rectangles, add them together. So this will give you total approximation to the mass of this whole plate. This only gives you approximation, and this approximation is going to get better and better if your area of that rectangle go to 0. Does this one look familiar? That's exactly is the definition of a double integral. The difference this time is instead of use fx, we use rho. The same thing, just a function of x and y. So double integral is not just give you the volume under the surface. It's also, if the function there is a density function, this gives you the mass of this very thin plate occupied by region D. In fact, the double integral has many more applications. Okay, another application we're going to talk about here is the moment of x about the x-axis and the moment about the y-axis. Now let's see what are they. Think about a simple case, x and y. Think about one point here. Just one point. This point coordinates x and y. This point carried a mass is m. So the moment about x-axis is the formula for that is this distance is y. Is y times m. That's the formula for the physics. Then m, the moment about y-axis is the mass times this distance, which is x. So x times m, let's give it a moment about y-axis. That's the simple case. You are the mass concentrated on one point. Again, now we have a thin plate. Okay. What is a mass? What is the moment about x-axis, and what is the moment about y-axis for this whole plate D there? Okay. So see, for the problem is more complicated because for the different point, your density will be different, and also the distance to the x-axis will changing. Right? This is your y. For the different point, your y will be different. So what we do again? The problem is they're not constant. Okay? So you make those smaller things, then you can treat everything as a constant there. So therefore, just concentrate on this rectangle. The mass for that rectangle, remember we can treat this as constant density times dA. Then this distance here, you just roughly think about it as a y, okay? Here's, pick the point here. This is a y, okay? So y times that. So what is this? This is give you the moment of this rectangle to the x-axis. Then add them together for all of those rectangles. Then take a limit. Okay. So this would give you the moment about x-axis, which exactly is the integral over dy rho xy dA. That's the moment about the x-axis for this whole plate. Similarly, we can find the moment about y-axis. Same thing. You just change here to x. Same reason. Okay. What is the center of the mass? Now the center of mass is like this. You just think about this for this whole plate. You just say the density functions like this. Just imagine all the mass concentrated on one point. This point we call center of mass, x bar, y bar, such that the moment, for example, about x for this whole plate equal to the moment. Okay, we just call this whole plate mass is m. Okay, just think about all the mass concentrated on that point. So for this point, we can find the moment, right? About x-axis will be this distance, the y bar. Okay, so y bar times m. Okay, the mass for this whole plate. Okay, how do you find this mass for this whole plate? Remember, we just did density function times dA. Okay, this gives you the mass for the small rectangle. Add them together, take a limit. Okay. So your y bar is 1 over m mx. Okay. Similarly, your x bar can be write as 1 over m over my. Okay. Okay, let me write more specifically. X bar is equal to 1 over m double integral d my x rho xy dA. Your y bar there is 1 over m double integral d y there rho xy dA. Okay, how do you find m? M here equal to d rho xy dA. So if you know how to integrate the double integrals, then you can find the mass, you can find the center of the mass. Center of the mass. The center of the mass is you find the coordinate x bar, y bar. Let's look at the example. Now we want to find the mass and the center of the mass of a rectangle with the vertices 0, 0, 1, 0, 0, 2. X and Y 0, 0, 1, 0. Here's a 1, here's a 2. Okay. This is our D. Okay, I give you a plate. Now we want to find the center of the mass, and also we want to find the mass of this plate. Okay. So the density function they gave to us, rho is equal to 1 plus, okay, let me put here, rho xy here equal to 1 plus 3 x plus y. Okay, before we do anything, we need to know the equation for that line. So any equation can be right y equal to ax plus b, right? You can find out what is a and b by knowing the 2 points. For example, 1x equal to 0, x equal to 0. Your y is what? 2, right? So you have this plus 2. And 1x equal to 0, or 1y equal to 0, x equal to 1. So a times 1 plus 2. Okay. So a there is a minus 2. Therefore, the equation for this line is what? Y equal to 2 minus 2x. Okay, first let's find the mass. Mass is double integral rho x y dA. We know this is double integral. Okay, first of all, density function is 1 plus 3x plus y dA. Okay. You can replace the dA either dx dy, dy dx, or r dr d theta. Obviously, this case is dx dy is better. Okay, so let's say dy dx. Okay, if you pick dx outside, so you have to, first of all, project this region on the x-axis. Find the smallest x and the largest x, which is 0 to 1, obviously. Then fix x in between. See what your y. Y is bigger than this point, less than that point. So this is your bottom curve. What's your bottom curve? Y equals 0, right? Bottom curve is y equals 0. Top curve is 2 minus 2x. So applications is easy. As long as you know how to do double integral, you just plug in the formulas. Okay, the inside integral about y, treat x as a constant. So you have y plus 3xy plus 1/2 y squared. This whole sense evaluate 2 minus 2x then it's 0. Okay. Remember here, replace y by 2 minus 2x. Then replace y by 0. So replace y by 2 minus 2x. Replace y by 2 minus 2x. Replace y by 2 minus 2x, then square. Then replace y by 0. Then you got a 0. Okay, dx. Integrate this one, you got 3/8. 8 over 3. So that is the mass for this triangular plate. Okay. Now let's find the center of the mass. So the x-coordinate for the center of mass, x bar, is 1 over m, double integral d here. You just integrate a different function, that's it. X rho xy dA, which is equal to, my m here is 8 over 3, 1 over that is 3 over 8. Double integral, we're still doing the same thing, okay, from 0 to 1. Then from 0 to, we integrate over the same region, so those two things are the same. Only thing is different is the function we try to integrate it. It's not just row there only. They have to multiply x. So it's 1 plus 3x plus y dy dx. Now you just need to integrate that. I'm not going to do that. I think you can do it. Give you 3 over 8. Find the y bar, the formula. Y times rho xy dA. Since we integrate the same region, 3 over 8, 0 to 2, 0 to 1, 0 to 2 minus 2x, y times rho, which is 1 plus 3x plus y dy dx. After you integrate that, it gives you 11 over 16. So you have to remember this section, as long as you know how to do double integrals. So the difference is the function you integrated is different. Okay. So how to integrate a double integral plus with the given formulas, then you can apply, you can find the mass and the center of the mass. For this class, I only ask you to be able to find the mass and the center of the mass.